Hi there, this is GCSE Physics. This is lesson 6, and this is the IV characteristics of a diode. So the objectives are to explain how we set up the experiment for measuring the IV characteristics of a diode, and then be able to draw the graph and do an explanation of why the graph looks like it does with any relevant values. So just like the last two videos, I'm actually going to draw the circuit diagram as it is because I feel it makes it easier to see how it's constructed. So that's the battery or the power supply combined with, we're going to need a variable resistor. So here's the variable resistor, which changes the voltage. Then just like last time, it's the same diagram. We're going to need an ammeter to measure the current that goes through the diode. Then a diode, it looks like this. It's kind of like a play button. So the current's allowed to flow through that direction. I'll talk about that in a moment. Then there's this. So that's the diode itself. The circuit symbol, the circle around it. Then let's finish this. And then just like last time, we need to put a voltmeter across it. So that's the diode. Oops. I'm going to try and make that a bit neater. There we go. And that's the voltmeter across the component, just like last time. So a diode, what a diode does is it allows current to flow in one direction and then not in reverse. So this is the positive side of the power supply and the negative. So the current will go this way, and current can actually go. The reason, just a note, just in case you don't know, the reason that current doesn't go through the voltmeter is because voltmeters have infinite resistance, so it doesn't even try. So the current will go through the diode, and that's okay, because it's going in the direction of the play button. However, if the current if you switch the power supply around and current tried to go through that way, it wouldn't be allowed, as we've got this pause section, so it just wouldn't occur. So hopefully that's helped with that one. In terms of the experiment, what we do is we measure current and voltage again, just like last time. But on the table, well, the table's the same, so voltage, current. The range of values is typically much smaller. It'd be between 1 and -1. So you might start at 0. It might be plus 0.1. 0.2, 0.3, all the way up to 1, and then the exact same, but obviously in reverse. And you do that by getting the power supply and switching the cables around all the way down to -1. And then you get the corresponding current values. So once again, we're going to talk about the independent and dependent variable. So the independent, if you've just watched the video before, I do apologize, it's the same thing. Independent is what we change. And what we change in this experiment is, of course, the voltage value. And then the dependent variable, which is what we are measuring. So measure is the current. Hopefully that all went okay. So let's look at what the graph looks like. So the graph looks something like this. So you see we've got, nothing in the positive. So this is the forward bias. In the forward bias, we get nothing, nothing, nothing. And then it goes, and you need to know this, 0.6 volts. They might give you the graph, or they might ask you to sketch it. And then this value normally gets you, an extra mark. And then we've got infinite resistance going backwards. So in the reverse bias, we get absolutely nothing. So this is the only one out of the three where the reverse bias is not a reflection of the forward bias. So in reverse, nothing happens. So very large current, very large resistance, no current. So hopefully that's okay. That's what the graph looks like. We might as well do an exam question. So here it is. So let's pause and have a go. Using the axes below, sketch the characteristic of a silicon semiconductor diode for forward bias and reverse bias. Indicate approximate values on the voltage axis. So it's the same as the graph which we've literally just seen. So nothing, 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 and then up it goes. And that occurs at around 0.6 volts. And then in reverse, we get nothing due to the infinite or very high resistance. It's probably a bit of a stretch calling it infinite. Okay, and then part B, describe with reference to the characteristic you have drawn how the resistance of the diode changes with the voltage across the diode. So the current start, this is something which you should have written, something to, of this ilk. The current starts to flow in the forward bias at 0.6 volts. Then you might have written that there's then, low resistance. From 0 to 0.6, the resistance is infinite or very high and no current flows at all. And in the reverse bias, the resistance is infinite, or once again, you can say very high. And that's about it. So it's pretty straightforward. Make sure you know the diagram and the general gist of the experiment. And remember, they always like, as part of your answer, to talk about switching the power supply off in between readings. Okay? And then there's obviously the independent and dependent variables, which you should mention in any 6-mark work as well. I hope you found that okay. Thanks for watching, and I'll speak to you soon.